Everyone for being here, especially those of you I have rounded up from the coffee place. Thanks for being here, giving up your coffee. I'm going to talk about a new thing that I've been getting very fascinated. And I started off this journey of working into the world of digital twins as a skeptic, that these things are just basically mumbo jumbo, they should not be used. And here I am saying they're great. So um, let me share with you how this all started. So first of all, I appreciate the fact that we are all here and we are going to be talking about different things. Two quick announcements. Today at 5 o'clock, there is a informal South Asia climate group, urban climate interest group, integrative, just meet outside. And tomorrow at 5 o'clock, Hunter Jones, who is here from NOAA, he is leading a discussion on city climate adaptation. So if you're doing anything with cities and climate adaptation and have an interest, please meet outside at 5 o'clock tomorrow before you start your 5:30 session. So half an hour, 45 minutes, we'll have that conversation and we'll do that. So let's have that. This will be really, really interesting, I hope. So what I'm going to talk about is that if you know the environmental movement, it started with the notion of NIMBY. I don't know how many of you really know how this was, that if you had a nuclear waste, for instance, or an environmental dump, the whole thing was, I don't want this in my backyard. So not in my backyard. But when we are coming to the climate information nowadays, we are coming to the era of SIMBY. I want climate in my backyard. It can't be something that is at a global scale. I want things which are in my backyard. I want to make a decision, but at a very, very local scale. And so this localization of this global change is one of the very important things associated with what is going on with the urban climate systems in particular, because we need hyperlocal information, whether you're talking about health impacts, where it needs hyperlocal information when you're trying to do things related to infrastructure development. And one of the important things to note, as we all realize, is that the data from the airport is not the data for your city. It's just that data at the airport. And so we need to create some localized information, especially for health impact studies going forward. Uh, this particular talk builds upon a upcoming workshop for which we have been working as a group, both with NSF and the WCRP Digital Earth Lighthouse activity related to digital twins, atmospheric urban digital twins, and you see some of the usual suspects there. And we will essentially be looking for partnerships and experts. All of you here essentially would have something to contribute and would love to have you participate in this effort as we start building up this whole concept of urban digital twins. So this thing also builds up on something we are doing on the UT campus, University of Texas campus, where we have essentially created a digital twin of the campus where everything, energy use, temperature change, environmental data sets are all now digitally available, put into a framework that you can start looking at. And it's a very interactive dashboard, but in a visual way, and that is available. And second is that the NOAA's AI for Earth system initiative, in which there was a digital twin effort, and there's a white paper that has come out with several of us that you can see. There is at the top, developing the digital twins for Earth system, what it is. And one of the big questions that is there right now is this whole definition of what a digital twin is. It can't be just every simulation that we are doing. It has to have certain characteristics. It has to have certain values, stakeholders, etc. So where does this all start from? It goes from the context that about a few years back, some of the studies started using deep learning for weather prediction. It started with a very simple framework that you can treat instead of the way we have been working with weather data sets, which has been in our Newtonian framework. You start solving equations, come up with a hydrodynamic balance, come up with the solvers, and you come up with this end solution. Instead of that, what people have started doing is you can take an image, and that image you can run through a series of algorithms, like you might have seen in some of the Bone Identity or other movies, where there's some very fuzzy image, and then they run it through algorithms, and it becomes sharper and sharper and sharper. The same way, you can work with this image of an output, and then from there you can start extracting information. So the change here, what has happened is, instead of working with data, meaning numbers, we are working with data meaning pictures. And you're working with these images and then trying to do a forecast. So that is a change that is coming here. Now, this was demonstrated that you could actually lay this in a global framework and you could take something very simple like a map of a temperature and try to, from the temperature map, try to predict a rainfall map. So, as a global experiment, this turned out very well. And you could try all different types of architecture that instead of a flat map, what if you actually consider some digital curvature and so sort of things, and whether there's a potential that by using sequential time change. So, the first question was from temperature to rainfall, same time. Now, from temperature to a forecasted rainfall at a future time. Again, simply using images and not using any of the quantitative approaches. Uh, this proof of concept then has been done by a number of people where they are now using test data sets where you can validate any new model where, for instance, you have cloud data, surface air temperature and precipitation, and you can try coming up with a reference point against a weather bench. So all these studies have been going on in a global sense. So, what we have been now doing is looking at it in the context of using some of this data and then trying to see whether there is any kind of advantage or any kind of predictive power at a very urban scale for some of these features where we have a global system. So, here we took a GFS, the Global Forecast System, and the deep learning weather prediction algorithm with a cubic sphere. And you can start looking at the feedbacks that come in, and there's a paper in Frontiers on that, and try to look at through running through a series of machine learning, deep learning algorithms, and you can start predicting the outcome of the uh, predictors here. But what is important is, yes, you can get the global picture of the rainfall patterns. What is interesting is the fact that you can actually, even without having prior knowledge, predict extreme urban events. So here's one example of that. 37 inches of rain in one day, Mumbai, July 26, 2005 rain. This system was, of course, very difficult to predict even with our dynamical models. But using this kind of a unit framework where you're using images, this still had a predictive power, and we could see a sort of like hotspot that is emerging in terms of where the rain occurred. And you can see that this is something that has a predictive power. So it is not just the range of means, but those black swan events are also being captured. And that has been the real value of where I started believing that there might be something of interest here. So this is an example of rainfall from a Hurricane Ivan making landfall in Houston. Again, you're trying to see how this goes into the context of the system. So where does this all go? I think right now we are at the point of that SIMBI where many of the municipal systems, climate and cities are really requiring a very local scale information. And in that, there is this need for development of high resolution products that becomes the framework of what we are calling a city climate collab, and for our concept of making the climate information useful to usable. So we have, of course, been working with things like WoodApt, which all of you know here at this conference, the portal that was developed. Of late, we have been working with the building height data set, which is the UT Globus, global building height data set, 1 meter data set across the globe. There's a talk by Harsh Kamath who will be discussing this, and we have this data available for a series of places. Uh, this can be interfaced with different products going forward. But what is interesting here from the urban perspective is a Meteogan that we have created for an urban digital twin, where you take the same framework of a coarser map and then generate a very high resolution output of a forward propagating algorithm. So this is the downscale bench. This downscale bench essentially takes data from any framework, any grid data set, surface data set, and you can start creating a supervised learning and come to a downscale product of a city of your interest. So I'll not go into this framework, but essentially the same approach. A map being processed, come down to a higher resolution, then you convolute that higher resolution output to a high resolution numeric output. And that's basically the framework that's coming in. Here's an example of that. A 5 kilometer our rainfall product over a place like Austin, and you can run through a series of this unit algorithms and come down to a 300-meter resolution precipitation product, which is occurring as a part of the statistical downscale technique that goes in. Here's another example with wind fields and how this gets applied for a fire and smoke digital twin, where you're looking into the framework of where it changes. with regards to the smoke patterns that can emerge, how the winds can flow around the city, how things can then actually be looked at in the context of the risk assessment. And because having this information at a very local scale is not possible when you're looking at airport data, but you need something at a very fine scale. Again, this is a dynamic predictive capability that comes with regards to using the framework going forward. So, what other things are coming up when you have this kind of framework? The whole issue of missing data, especially for tier 2, tier 3 cities, you don't have a lot of urban data sets, and models need to be run at a global scale. And so, trying to come up with this kind of information with very limited data sets. So, here's a case of Chicago. What if we only had 5% data? Can we still use some sort of a deep learning algorithm and then put this into a framework to create the whole plan area? This is the one OpenStreetMap framework. Created the We now have a data continuity with regards to the NDUI, normalized differential urban interface index, which can be a combination of DMSP and the WIRS data that is available. And that is also now part of the framework here. But very exciting to us is right now the interfacing we have with regards to the video games with urban weather forecast. So what this paper came out in PNAS Nexus. This is a deep learning based morphology for city scale environment. What it does is you can take at video images from a computer graphics as you're doing a video game, and you can actually extract out the information as if it is a real LiDAR imagery. And from there, you can construct what is the street height, what is the canyon height, and put that information into a weather model. And then this becomes an interface for dynamic weather prediction. So, this is an example of where you're using weather forecasting from the context of a video game going into a real life environmental feedback, going into the framework for if then scenarios, coming up with projections about the. I've been told to please stop, which is what I should do right now. And I'll just start by saying that out of this, we have now created the City UT Climate Collaboratory, which would be going into the framework of creating this data, working with stakeholders like we have Mark Kuder from the city of Austin, who provides us the stakeholder framework about what is needed by the city and community groups, and put all this information for usability. So where I'm going with the urban digital twins is there is tremendous promise here to take the global information and make this very localized. And working with stakeholders, I think we are now ushering into an era where over the next 3 to 5 years, we are going to get highly personalized urban climate information possible. And I'll stop there, and thank you very much.
All right, so we have time for maybe one, maybe a few questions.